Sweet. All righty, let's go. So this is workshop 3 out of 4. We're going to be talking about the backend. So first, a quick recap. What have we learned so far? In the first 2 hours, we've done a lot of stuff. We've reviewed 3 languages, HTML, CSS, and JavaScript. And we've learned an entire front-end development library in React. And that's actually a lot of stuff. You guys should be really proud of yourselves. It's a lot to take in, so it's okay to be confused. If you need to ask more questions, definitely do that. Go to the questions doc, it's linked there. You can also find the slides for this presentation linked in the questions doc as well. So we've done a lot of great stuff. Again, just a quick recap. HTML does your organization and your content on the front end. CSS makes things look good. JavaScript allows your website to function and handles the logic of all your buttons and such. React is this front-end library that allows you to succinctly structure your web app into various components, and it has this tree-like structure. And this is what it looks like in code. Every class component is going to have a constructor and a render function, and most of them will have components in mind as well. So that's all the stuff that we've learned so far. It's a lot, and we're going to cram more in this next hour just because we can. So we're going to learn about new stuff, backend stuff. So first, we'll talk about what is front end versus backend. This might be review for a good amount of you, but it's also going to be new to others. So just keep that in mind. We're going to build our understanding from the ground up. So we're going to talk about front end versus backend, client versus server, what an HTTP request is, how APIs work, what are APIs, how you can make your own. And then we're going to talk about databases, how they work, why they're important in web apps. So a lot of stuff to cram in this next hour. Again, use that questions doc if you need it. I'll be going somewhat fast. There will be time for questions in the middle. Okay, let's talk about the backend. So I think this picture sums up how websites work pretty well. The user of your website is floating around on the surface, and what they see of your website is the front end. The part that they can see is the front end, but your website, all the stuff that you put into your website, all the logic, all the code, is not all shown to the user. There's a lot of things going on that the user cannot see, that the user is not aware of, that the user cannot access. So the front end is what the user can see, what they can interact with. The back end handles all of those, all of the website's functionality that the user cannot see. And so if we want to just summarize like the various tools that we have, HTML, CSS, and JavaScript, those are all front-end tools, and React as well. But then in the backend, we have these new things that we're going to talk about: MongoDB, Express.js, Node.js, etc. So yeah, so let's talk about this backend thing. What is going on here? The backend is like pretty mysterious to the user. The user has no idea what's going on. It should feel like voodoo magic to them. And so just saying it all again, the stuff that we know already is called the front end. It's called the front end because it's like at the front of the like work stack, which just represents the workflow of like the user using your website. The first thing that they see is the front end, and then as data passes through, it passes to the back end and comes back. Okay, so I just talked about the back end, but in order to understand it better, let's go through an analogy. So this is Taco Bell. We're going to see Taco Bell a lot in this presentation, so be prepared for that. Pretend we're at a very fancy Taco Bell where you have a waiter or waitress who takes your order. So you go to Taco Bell, you sit down, you talk to the waitress, you order your Doritos Locos Tacos. You talking to the waiter and interfacing with the waiter is like you using the front end of your website. The back end in Taco Bell, I'll give you like 5 seconds to think about it, but the back end in this Taco Bell analogy would be all of that stuff in the kitchen in the back. I don't think Taco Bell's kitchens look quite this nice, but you get the idea. It's like the kitchen, the stuff that's going on in the background that you cannot see. But all of it is important in order for you to be able to consume your Doritos Locos Tacos. Okay, so that's front end versus back end. That's going to be very, very similar to this next section, which is client and server. So what is a server? You've probably heard the word server before. As a matter of fact, most of you are on the Discord server. So that's a server. What else is a server? Do people have people heard server in any other context besides Discord server? So you got a Minecraft server. Yep, Minecraft server, web server. Yep, those are all good things that are servers and exist. So you got this Discord server, right? Minecraft server. Yep. Xbox. I actually had no idea Xbox had a server, but I think I must have Googled that at some point. Xbox has a server. When you think server, maybe you think of like this just big stack, big array of computers. And that's like basically correct. A server is just this big centralized hub of, you can think of it as like one mega computer basically, but it's like a big centralized hub of computers that lives somewhere, probably in the middle of nowhere, like in Oregon. Sorry if you're from Oregon. And there's, AWS, right? People have heard of that before, I'm sure. So those are servers, but let's talk about, instead of talking about examples of servers, let's talk about exactly what it is. So like I said, server, you can think of that as just this big mega computer. And basically, there's going to be this process that's running constantly in the server. And whenever a user uses their laptop to log onto a website, they're going to be accessing a client. So the user's the client, they see what they see on their laptop, and they talk to the server, which is this remote computer in Oregon, right? And they establish this connection. So there's a server, there's a computer in Oregon, there's the user's computer, which is the client. The client might need to send requests to the server. For example, when you go to facebook.com, you need to load up all of your friends who are online. So how do you know who's online? You send a request to the server, and the server is going to send back a response. So that's how your computer can talk to the server. Your client talks to the server. And again, client versus server is analogous to front end versus back end, right? So your client is like the front end. It's all the stuff that you can see and talk to. The back end is the server. It's that remote computer that's going on somewhere else. So the nice thing about this model of this system for creating websites is that you can have one centralized server. Facebook can have one centralized server, and many clients can connect at the same time to the same server. And all of them can send requests and get responses back from the server. Okay. Okay, so why might we need a server? Let's think about this one for like 15 seconds, and then people can start shouting out answers or putting them in the chat. So why would we want a server for our website, for our, like for Minecraft, for whatever? What's like the benefit of having a server versus like this? I guess an alternative model would be like a decentralized model. Okay, yep, storing data, right? You want your server to be able to store and access data. Yep. I saw something else. Security. Yep, security is great. We don't want everyone to be able to access all the data directly from their computers, because if their computers get compromised, the whole server's down, the whole website's just done, right? So we want to make sure the meat of the website, all that advanced stuff that's going on is locked behind doors that we know are secure. That's why we have a centralized server. I think someone said 24/7 uptime. That's correct as well. Because we have the centralized server, everyone can access the functionality of the server 24/7. So those are all great points. Here's just a few of them. So file access, right, writing and reading data, centralization, so that everyone can be connected to everyone else, as well as security, so that you can protect everything in a centralized location. Okay, so hopefully people understand what a server is by this point. Again, it's just a centralized mega computer that does a lot of functions to help out running your website. Let's talk about what a server is written in. So there's a lot of different language, a lot of options that you can use. Some of you might have used this before. I know someone was talking about Flask this morning, but we are going to be using Express.js because we are going to be running JavaScript code. All the others are valid ways to make websites, but this is just the one that we're going to use. So we're going to use Node.js, which is basically this framework. I think it runs on some Google stuff, but basically it runs the JavaScript on your server. And Express.js is a framework that sits on top of Node.js that allows you to easily structure your JavaScript code in ways that are conducive to backend functionalities. If you want to understand the difference between these two and how they interact together better, I encourage you to Google it, but we don't need to worry too much about that. Okay, one last time, just to really drive home this point, because I think it's super important, understanding the dichotomy between the client and the server. Your client is you logging onto the website on your computer using Chrome, Firefox, or Safari, or Internet Explorer, but probably not Internet Explorer. And then the server is just this collection of computers, or you can think of it as one mega computer that lives somewhere else that will serve a bunch of functionalities that you need. And your client will connect to the server via Wi-Fi and some protocols. So there's like this big internet connected system where everyone is logging into their clients and talking to the servers. Okay, cool. Hopefully you'll understand that by now. Sorry for people who know this already for this repeating information, but I think it is really important to understand the high level idea of what's going on. Here's a text-based recap, just so that for people who learn better that way. When you visit a website, you're opening up a client. So when you go to facebook.com, you're opening up a client. The device that stores all the information, all the important stuff of the website is called a server. Facebook has a server somewhere in the world. And then when you open up the website in your browser, you're opening up a client that connects to that server that requests data from there so that you can read it on your screen. Okay, cool. So that was servers, clients and servers. Let's talk about HTTP. Okay, so there's this question, like, how do we send information? When I open up a client, I want to be able to get information from the server, but how do I access that information? I can't like send an email and then wait for a response. That's too slow, not efficient enough. We need a very specialized protocol for sending these requests and getting responses. And so if you've ever opened up a website before, you might have noticed that at the beginning, there's this string of 4 or 5 letters. It's either HTTP or HTTPS. So that is going to be the protocol for how your website connects to the server and receives information. So HTTP stands for Hypertext Transfer Protocol. I believe HTTPS stands for Hypertext Transfer Protocol Secure. Someone can fact check me on that. And basically what it is it's a method, right? Protocols are methods. So it's a method of communication. It's a way we communicate data. So when I click on Akshaj's Facebook profile, I need a way to tell Facebook, hey, I want to see Akshaj's beautiful profile picture. And Facebook needs a way to send me that profile picture back. Okay. And if we go back to talk, okay, I think this is kind of silly, but if we talk about Taco Bell, HTTP is just your waiter, right? It's like the method by which you order your food. It's the method by which you get the things that you want to get from your server. So HTTP requests, they consist of these components. So there's the URL that you're requesting to. So for Facebook, I'm sending requests to Facebook, right? So it needs to be facebook.com something something. There needs to be a method. We're going to talk about that later, but that's like get or post. If you've heard of those before. You need some request headers. I wouldn't worry about those for the purposes of any web development stuff, but when you get into more advanced things, sometimes you'll need like authorization headers, or these are just meta like tags attached to your request that can provide some additional information, like verifying your identity. But then this green part at the bottom here, that's what we care about. That's like the bulk of your HTTP request. It's called the body, and that is going to contain all of the information that you care about. So going back to when I asked for Akshaj's profile on Facebook, my request body to Facebook would probably contain like user that I'm looking for, Akshaj, right? And then when Facebook sends me a response, it's gonna contain a lot of information like Akshaj, age 20, birthday, September 2, profile picture, this set of images, etc. So the body is what's going to contain all of that information that we care about. Okay, so when we talk about this in code, it's gonna be stored under this variable called rec. So rec is going to represent your request, and if you index into the body, that's where you're going to be able to see all of that information. Query is, I think query is for get requests, bodies for post requests. I would just think about it all as body for now. Sorry if that's confusing, but like the way a get request would work is if I wanted to get something, let's say I wanted to get something from the server corresponding to this website, I would go to this, I would get from this URL. And so what this is saying is I want to get a comment whose parent is equal to this ID. So this is an HTTP GET request to some server out there. And then the server, once it receives this, is going to respond back with the appropriate comments. Okay, so don't worry if you can't quite wrap your head around this yet. I'm just going to throw a lot of stuff at you and then talk about it over and over again, and hopefully eventually it sits in. Okay, so there's a variety of different HTTP methods that we can use. There's GET requests, POST requests, which you might have heard of, and those are the only ones we really need to use. But there's also PUT requests and delete requests, and a few more. But the main ones that we're going to care about, again, are GET requests and POST requests. So what do GET requests do? They get data. So if you want to retrieve data from your server, you send a GET request. If you want to write data to your server, for example, you are creating a new comment on Facebook, you would be writing data into Facebook's database, right? Writing data to Facebook. you would need to put that in a post request. So post request, create data, get requests, retrieve data. Alrighty. Let's not worry about this. Let's talk about responses that you can get. So after you send a request to the server is going to receive that, it's going to process it, and it's going to send you a response back. And attached with its response is going to be this status code that's going to tell you how the server was able to process your request. They either are going to start with 1, 2, 3, 4, or 5, and then have 2 other numbers. And I'm guessing that you've probably seen a few of these. So let's go through a quick montage of what they can look like. So the first and perhaps the most iconic is the 404. You've probably seen this before, maybe when you go to GitHub and you're not signed in and you're trying to view a private repo. But basically the 404 error happens when the server cannot find the information that you're requested. So 4xx, that's what that corresponds to. The 200 status code is good. That means your request went through successfully and everything is okay. The 500 status code means that the server ran into an error when trying to process your request. So either the server is buggy or you sent a request with some weird data that made the server get confused. 400 is a bad request, which means you probably formatted your request incorrectly or did not provide all of the necessary information needed to make that request. And so like here's a summary of what all of the status code represent. Again, you can see more of this stuff at the link below. So in WebLab, or in this workshop, we're going to be aiming for this 2xx. That's the stuff you want to see. The reason we're going over this is because when stuff goes wrong, you can actually debug better if you understand what the various status codes mean. Okay, cool. And if you want to see these requests in action, you can actually do that right now. So if you go to any website and you inspect the element and you go to this network tab here, you can see that like all of these are HTTP requests to Google. So if we look at as like the slides load, each slide is probably in a request somehow. So like all of these are HTTP requests being handled by Google, which is pretty cool. So you can kind of see that, at least that it's happening right now. So this one's like sending an HTTP request to contacts.google.com, passing in some data. That's why there's like all that random strings at the end. Those are just values of data that we're passing into the request body. Okay, let's recap HTTP real quick. So all you need to know is, at a high level, HTTP is a way to communicate over the internet. It's a method, a protocol of communication. The two most important types of ways of communicating that we care about are GET requests, which are ways to ask for information, and POST requests, which are ways to contribute new information. Your client is going to use HTTP requests to interact with remote servers. So your local client, your computer, the website you have open is going to interact with remote servers via HTTP requests. And you commonly use these to interact with an API. We're going to talk about that next. But at this point, just want to pause, make sure everyone gets their questions in. I think the questions doc looks okay. Anyone have any questions they want to ask right now. All right, let's talk about APIs. Okay, so what's an API? An API is a set of rules. Yeah, that's all you really need to think about. An API is a set of rules. It's a set of ways that your various clients can interact with the server. So each rule is known as an endpoint. That's the specific terminology that we use with APIs. So each rule is an API endpoint, and they describe how you can access data from the server or write data to the server. So as an example, this website might have a, maybe it's like an animal shelter website or something. And it has an API endpoint or a rule, right, for finding your pet by its ID. So this would be a get endpoint where you can find your pet by the pet ID. So let's say this website was called mypets.com. If you went to mypets.com/pet/ and then you input your pet ID, it would return as a response your pet. So maybe your pet is this object represented by this thing over here. So it has ID 0, and maybe its name is Doggy. Cool. So if we think about Taco Bell, what's the API in Taco Bell? Remember, the API is the set of rules. It's the set of ways that you can interact with the server. And if we remember from before, the server is the kitchen, right? So how do we interact with the kitchen? What's the set of rules for telling Taco Bell what we want? It's the menu. At Taco Bell, the menu is the way of telling, Taco Bell, the kitchen, like, what do you want to get? Or the set of things that you can ask for. So that's what your API is. It's like a set of rules that you can use to interact with the server. And so if we wanted to think about like some possible endpoints in a Facebook API, maybe one of them is called get all messages, right? So there's this get endpoint in Facebook's API that's living on Facebook's server, right? So Facebook API living on Facebook server, and there's a get endpoint for all messages. And so whenever someone wants to find out all of the messages at Facebook, they can go to this endpoint and it will send back res.send right here. It'll send back all of the messages. Don't worry if this code looks a bit like jank or confusing. We'll go over more of the syntax in the final workshop where we build our own website. But I think the high level idea should make sense, right? Like this is a get API endpoint. The name is all messages. It's going to take a request and a response type. And what it's going to do is it's going to find all of the messages, and then it's going to take those messages and send them back in the response. So this is an example of a way you can create your own API endpoint and include the logic behind it, the necessary logic. Okay, so that's a get endpoint. Hopefully you've had enough time to digest that. Let's talk about this post endpoint down here. Post endpoints are ways that we can store data, right? So the way we're doing that, we're having this post endpoint called new message. So whenever someone goes to facebook.com and they want to create a new message, maybe they're messaging their friend, they're going to call this endpoint. So what it's going to do is it's going to take this message object and it's going to create a new one with the user ID corresponding to the user ID that was passed into the request, the user name that was passed into the request, and then the content will correspond to the content that the user just typed. So if the user with, let's say you're trying to slide into Emma Watson's DMs and you say, hey, what's up, Emma? That would be part of the content. And you create this new message and we save it. So in that way, we've successfully posted this new message. Okay. On the front end, the way we call the API from the front end is we just do something like this. So we get all messages from the API, and then we're going to take the messages that we received and maybe we're going to store them in the state on the front end. And then in that way, we can interact with it on the client. Okay, cool. So that's a brief glance of how APIs can look like in code. When we code our own websites, we're going to want our websites to have APIs because we are going to want our websites to have a front end and back end, which means that our front end needs a set of rules or an API, a set of ways to communicate with our back end. So we're going to have to write our own APIs for our front end to use. If you're creating your own social media website, like we will be doing later today with Facebook, we're going to need some of those endpoints that I just described in order for the front end to call. And again, your API lives on your server, right? It's the menu that lives on the back end that the front end can access. And so all the clients will be connecting to your server using the various API endpoints that you wrote to read and write data, as well as perform any other functions. Let's pause real quick. Okay, questions doc looks fine, chat looks fine. All right, this last section is probably the most comprehensive. Let's talk about databases. So we've talked about a bunch of rules and ways that our backend can work, but we still need to talk about databases, how databases work, and really why they're so important. First, let's think about Taco Bell and think about what the database would be in Taco Bell. Well, if we think about it, the menu, that's like the API. That's how we access the database. So we retrieve information from the database using our API. So if we think about the database, what it should be is at Taco Bell is it's like the freezer where they have your frozen Crunchwrap Supreme. And then when you order it with your API, they take it out of the freezer, they put it in the microwave for a little bit, and then they send it to you, right? So in a similar way, your server, when you make a GET request, it's going to access the database. It's going to retrieve information that it needs. And maybe it does some pre-processing with that information on the back end before it sends over a nice, neatly packaged version to the front end. An example, so let's say that I'm visiting Akshaj's Facebook page and I want to see Akshaj's profile picture, right? So I'm going to make a GET request to the backend for Akshaj's profile picture. What the backend is going to do, what the server is going to do is it's going to say, hey, database, I need all the information that you have on Akshaj. So it's going to go into the database, pull out this whole big file that corresponds to Akshaj, but it's not going to return all of that to the front end. It's only going to pre-process it. It's going to take out Akshaj's profile picture and only that part and send it back to me so that I don't have to deal with all of this extraneous data that I don't care about. Okay. Talking more about databases, there's a lot of different types. You might have seen some of these before, but the one that we are going to be using and teaching you is MongoDB. And there's a couple reasons for this, which we'll get into later. But I think most importantly, MongoDB is probably the most intuitive out of all of them. Okay, so what is a database? It's an organized collection of data. And the database management system is going to be software that facilitates interactions with the database. So MongoDB is going to be the database management system. And it's going to allow our server to facilitate interactions with a database. It's going to allow our server to talk to the database, to read from the database, to write to the database. So here's how it would work. This user, you can think of it as the backend. What's actually going on, like the user is making a request to the backend, which is then utilizing this database management system to talk to the database. But I think for the sake of this demo, just as a user, it's saying, hey, get me some information from the database. So the database management system, which is Mongo, is going to do that for us. It's going to retrieve information from the database and bring it back. Very nice. Okay, and in the same way that we can retrieve information from the database, we can also write information to the database. So we can have an object, like a set of data, maybe in a JSON or something, and we want Mongo to write it to the database. So we're going to say, hey, Mongo, take this and put it in the database for me. And Mongo's going to store it where it needs to go. Here's some pseudocode for what that would look like. So if we wanted to get stories, maybe we could assign this variable stories to the result of the Mongo query, give me all the stories. Maybe we only want story number 4. So we could tell Mongo, hey, give me the story with ID 4. Mongo can do that. Maybe we want to write some data. So Mongo can do this as well. Put this object in the database. Maybe we can delete stories. So let's say I wrote a bunch of bad stories that I don't want anymore. I want to delete all of them. Mongo can do that as well. And it can also update data that already exists. Okay. So that's what a database is. That's all the things that it can do, how it's useful on our website. Let's talk about exactly what it looks like. So there's 2 main types of databases that are used. The first is called a SQL database or relational database. SQL or SQL stands for Structured Query Language. So the way these work, all the data is stored in a bunch of spreadsheet-like tables. So the database just consists of a bunch of tables just floating around everywhere, and they have like various pointers to each other. So maybe you have this table for stories where each story has like some content and a creator name and some ID. That would be one way to store data. But this is like a little complicated. I think it's a little bit hard to like wrap your mind around how this would work for something that, like, this is a very straightforward case where the only thing you're storing is stories. What if you also wanted to store a bunch of user information? Like, what if I wanted to know Matt's location or something? How would I store that? Would I also store a location tag for each story? That seems a little bit unnecessary. So maybe I'd have like a separate table for users where I have like ID 0, Matt's location is Boston. But I think it's a little bit tricky to think about how all of that would fit together. Like, what if I wanted all of the stories that corresponded to people who lived in Mexico? You'd have to do some like bouncing back and forth. So let's not worry about relational databases. Instead, we're going to be using this other model of databases, which are document databases. And MongoDB happens to be one of those. So let's talk about how MongoDB works. MongoDB is going to interact with a type of database where we store documents rather than tables. Basically, you can think of those as just really, really large JSON objects. If you haven't heard JSON before, you can think of JSON as like a really big JavaScript object. So the reason it's called a document database is because we call these documents. So each individual story that we're storing in this database would be called a document. The set of stories is called a collection. And you can kind of imagine how this would be stored as a big like Python dictionary or JavaScript object, something like that. So again, this is what we'll be using. I think it's a lot simpler to reason about data stored this way. Okay, so let's look at what a section of the MongoDB hierarchy might look like at Facebook. So we have this big cluster, this Facebook database. And then the database is going to consist of a bunch of collections. Collections are types of objects that we can store in the MongoDB, such as posts, comments, users, etc. And then each collection is going to have a bunch of documents, right? So for every post on Facebook, there's going to be a document under the post collection. And it might have an ID. It's going to have some content. It's probably also going to have other things like user ID for the user who created that post. But it's going to have all of that information stored inside the document. You can see like the comment document here is a little bit more fancy. It has a parent with ID 3. So maybe this comment corresponds to this post. This is kind of how MongoDB is structured. And when we want to write stories and comments, we can just pass those into MongoDB, our database management system, and it's going to write them into the database on the server. It's going to write them into the database under their respective collections. Sweet. So MongoDB is great. There's a lot of really smart people working on this piece of software. And so write speed, memory usage, all these things are optimized. One thing you might be thinking about is, what about failure? Like what if the hard drive that we're writing on breaks? So, Facebook is this multi-billion-dollar successful company, and they have all of their data stored in this database, this hard drive in, say, Oregon, right? And then, there's a natural disaster in Oregon. Oh, let's say Austin, right? Or Houston, Texas. There is something going on there recently. So let's say Facebook's storing all of their data in Houston, Texas, and then boom, hurricane, something or whatever, power goes out, database dies. All of Facebook is just gone, right? So that's not good. That's actually not how databases work. It turns out humans are pretty smart, and we've thought of ways to get around this. And so MongoDB specifically solves this by using something called Mongodb Atlas. And the idea is we run MongoDB instances on the cloud. And so this means that there's no like single physical point. There's no single physical point where there's like vulnerability. So a lot of this is hosted on AWS. Your database is maintained for you online, and anyone with the right permissions can access it. So you can also share your data with teammates or with other apps that might need to use the same database. Okay, so this is what it looks like with Atlas. Your server.js, the backend server that maybe Facebook is running in Oregon, talks over the network to the database, which is running on the cloud everywhere. And multiple servers can now connect to the same Mongo instance that's running on the cloud. Okay, so one other thing that helps this, so like when I say it's hosted on the cloud, it's not like there's just this cloud in the air where the data is being stored. It still has to be stored at a physical location somehow. But the reason we can think of it essentially as being on the cloud is because there are these duplicate databases, right? So you have the primary MongoDB, maybe that's in Austin, but then you have the same data replicated, maybe in another database in Springfield, Illinois, or Boise, Idaho. I don't know, some random locations, or in India or something, right? So all over the place, you have the same database duplicated on computers, so that on some hard disk somewhere. And so this ensures that if something bad happens to one of them, there's backup sort of pathways that our server can use to still function and run the website correctly by viewing the data that we want to see. Okay, let's do a quick overview, like walkthrough of what this would look like. So you're the user, you're on your client, you're opening up this website. Let's say you want to get a story or get some information. So you send a GET request to API story. Luckily, there's this story item on the API menu, right? So that would have had to be coded into the API that's running on the server. But assuming that exists, we can do a GET request to that API endpoint, to the story endpoint. And the server is going to receive that GET request. And it's going to process it. And it realizes, okay, this client is asking for stories. So what I'm going to do is I'm going to talk to Mongo, talk to the database, right? So I'm going to retrieve the stories from that database, which is running on the cloud. And the database is going to send me the stories back. Great. Now server knows about the stories, can process them in any way it needs, and send the stories back to the client. So that's how that would work. It's pretty straightforward, actually, in the long term. When you think about how everything is working together, it all fits together pretty seamlessly and logically, but it's a lot. So if you still don't understand it, that's like totally fine. It's new, right? There's a lot of this stuff is new. So it'll just come with time. And yeah, let's just do a quick summary of what databases are. So databases are a solution to our problems when we need to save information permanently. So we can use a database to store our data, and we can ensure its success by duplicating it at a bunch of other places so that it's essentially stored on the cloud. We're going to use MongoDB as our database so that it's not confusing. So that basically all we're doing is we just have this big collection of objects, of documents that we are storing. And I think it's also pretty intuitive to code with after a little bit. So later today, in Akshaj's workshop, we'll be writing code with MongoDB, as well as all of the other backend sort of ideas that we've learned. So sorry we didn't get to do any like hands-on coding. We didn't get to get our hands dirty in this workshop, but for the next hour, you guys will be coding with Akshaj and writing code that has both a front end and a back end according to the sort of things that we've taught you over these first 3 hours. So with that, I think that's the end of my presentation. Any questions about back end stuff?